All right, today we are starting chapter 7. This is where I start getting excited. If you guys thought I was excited before, you're in for some excitement. We're going to be looking at, in section 7.1, we're just going to talk about the discovery of cells and how we got to know what we know today about cells. Some of the people that played a significant role in the discovery of cells, and so on. Inside this section, first, we are going to talk about the history of the cell theory. Then we're going to talk about what the cell theory actually is. We are going to talk about two types of microscopes. And then we're going to talk about the two basic cell types. Those are the topics that we're going to cover today. All right, let's get right into it. The history of the cell theory. There are a number of people that played a significant role in what we know about cells today. The first one is the person that invented the microscope, and his name was Anton van Leeuwenhoek. Everybody say that. You guys are awesome at that. Say it one more time. Go. All right. He was a Dutch scientist. So we have something in common. Woohoo! Actually, if you were to translate that name in English, Leeuwen means lions, and hoek means a corner. So a lion corner, I guess that would be the translation. So he was a Dutch scientist, and he's considered to be the first microbiologist, which makes sense if he's the one that invented the microscope. Actually, I found his signature online, so I thought I'd put that in there. No relevance to what we're talking about, but I was just excited to see it, so I said I'll put it in here. All right, his first microscope. He invented the microscope, and you're going to see what his microscope looked like. And this is a picture of the first microscope. It's ghetto. All right, now let's look at this and dissect it a little bit. Let's dissect the microscope. Here we have a lens. This is the lens. That is the lens. All right, so it's obviously not as high-tech as the one that we use today. Where's the light coming from? The sky, the sun, any natural light that's there. That was the first, or this is similar to the first microscope that was invented. So obviously we've come a long way. We're going to look at some microscopes in this class, and we'll do some experiments with those. Next person we're going to talk about, his name is Robert Hooke. What's his name? Robert. What was the first name that we looked at? Okay, Anton van Leeuwenhoek. Do you need to memorize these names? Yes, you do, because they will be on the test, so make sure you get those names. Robert Hooke is the next name we need to know, and he was the first person to see a cell. He actually observed it while looking at cork under a microscope. Question?
Do we have to know how to spell their name?
Yes. Whoa. Oh no. If it's misspelled detrimentally, then you lose all the points. If you kind of spelled it a little bit incorrectly, you might lose a half point or something of that sort. It just depends on how bad you do it.
Shorten whatever his name is.
What is his name? Leeuwenhoek. So start studying from now so that you can know those names. Let's continue. He observed those cells in cork. And the next person we're going to talk about now, his name is Matthias Schleiden. Everybody say that.
Matthias Schleiden.
Okay, with a name like Schleiden, where do you think he's from? Germany, right?
What it says on the sheet. Yes, go German.
Okay, yes, it does say that on the paper. He was a German botanist. What is a botanist?
Botany, like plants.
Plants, right? Okay, and he was the one that concluded that all plants have cells. Okay, let's go back to the beginning. Who invented the microscope? Okay, I'm going to say it one more time, and then you guys are going to say it after me. Anton van Leeuwenhoek.
Anton van Leeuwenhoek.
The first person to see a cell, what was his name?
Robert
Robert Hooke. And the one that says that all plants have cells, his name is? All right, sweet. Let's go to the next and final person in this section. His name was Theodore Schwann. What is his name? Theodore Schwann. Okay. And he observed that all animals were also composed of cells. So we have Anton van Leeuwenhoek, first one to the one that invented the microscope. Robert Hooke is the first person to see the cell. Then we have Matthias Schleiden. All plants are made of cells. And then we have Theodore Schwann. All animals are made of cells. Now, the way I remember these, at least the last two, these are relatively easy to remember, especially this one. A swan is an animal, right? Yeah. And it kind of sounds like this guy's last name. So Theodore Schwann, all animals are composed of cells. Does that make sense? Okay, so that's an easy way to remember it. Now, for the Schleiden guy, I used to have a really good way of remembering it, but I painted my walls so it doesn't apply anymore. Do you guys remember the color of the walls before? Green. Like a pukey green, right? Okay, so this was the way we used to remember it, and it's not going to be as effective now because you can't see the green. Okay, but this was it. All right, this is how it went. And actually, when I painted it over, students would come in and they'd be like, how am I going to remember Schleiden? And anyhow. I know, right? Okay, so this is how it goes. Plants have leaves. Leaves are green. You guys should see your faces. Leaves are green. Green was the color of the walls in this classroom. And the color of the walls in this classroom looked like puke. And whenever I looked at them, I used to think to myself, Schleiden. And that is how we remember. What's his name? That is really good. What are you talking about? It's not going to be as effective this year. I apologize. And it's possible that you guys will never be able to learn Matthias Schleiden because I painted the walls. But hopefully you can still find a way to do it. Let's move on now. Let's move on now to talking about what the cell theory actually is. It's composed of three main ideas. It has three main ideas. Idea number one, all living things are composed of one or more cells. Idea number one, all living things are composed of one or more cells. Idea number two, the cell is the basic unit of organization of organisms. So the basic unit of organization of organisms. And the third idea is all cells come from pre-existing cells. So idea number one, all living things are composed of one or more cells. Number two, cells are the basic unit of organization. And number three, all cells come from pre-existing cells. Help me out and fill in the blanks for me. All living things are composed of one or more what? Cells. Sweet. The cell is the basic unit of organization, and all cells come from pre-existing cells. You guys rock. Let's talk about the two types of microscopes. First, we're going to talk about the light microscopes. And even within the light microscope, we have two kinds. But the light microscope uses light and lenses. All right, the simple microscope, we have the simple light microscope that uses one lens and natural light, like the one that Leeuwenhoek invented. Please put this away. And then we have the compound light microscope, which uses multiple lenses. I have a bunch of them here, so I'm going to take one out for you so that we can look at this light microscope. Microscopes can be really expensive. You can get a microscope for a few $100s. You can get a microscope for many thousands of dollars. Well, it depends on what you're using it for. All right, so let's look at this microscope here. Okay, it's not plugged in, but we're going to act as if it's plugged in. here you can see that we have a lens here that you look through. And then we have some lens here, and you can rotate this depending on the amplification that you want, the magnification that you want. You put the specimen on here, and we're going to be doing some of that. And where's the light source? On the bottom right here. Okay. There's a switch that you can press here that causes light to shine, and it goes through the specimen, and you can see it. So this is what kind of a light microscope? Compound light microscope, because it has multiple lenses, and it has a switch that you can turn on the light and all that good stuff. Now, these light microscopes can magnify images or specimens up to 1,500 times. How many times? 1,500. The next type of microscope, not the light microscope, but the electron microscope. If light microscopes use light, what does this use? Not, well, what exactly does it use? Electrons, right? And we're going to talk about that. It was invented in the 1940s, and it uses a beam of electrons. And you can see an electron microscope here. That was one of the first ones invented. These are huge machines. And these can magnify specimens up to 500,000 times. All right? Because obviously, electrons, are they large or small things? Small. Really small. Those are the particles on the outside of the atom. And they're really small. And you send a beam of electrons to the specimen, and then it reflects onto a surface that you can then see the image. There are two kinds of electron microscopes, just like with light microscopes. And those two kinds are scanning electron microscopes, or for short, we call them SEM. And what those do is it scans the surface of cells. So it just allows you to see the surface. And then we have transmission electron microscopes, and that allows you to see the inside structures of the cell. So which one would give us more detail? The transmission, right? Because it actually allows you to see the stuff that's on the inside. And as an example of that, here we have an SEM. What kind of cells are these? What kind of cells? Red blood cells, right? All right, you can see the surface of them. You can see some detail. But then here, with a transmission electron microscope, you can see the organelles that are on the inside, and you can see much more detail.
That'd be cool.
All right. These are expensive microscopes, but they do give us the ability to see a lot of detail. All right, so now let's talk about the two basic cell types. Prokaryotes. Those are cells lacking internal membrane-bound structures. Cells that don't have these membrane-bound structures, and we're going to talk about that in more detail. Eukaryotes, on the other hand, they do contain internal membrane-bound structures, and these structures we call organelles. So there are a number of organelles inside a cell, eukaryotic cell, and we're going to look at some of those. They also contain a nucleus, and the nucleus is an organelle that manages cellular function. It was first observed by Robert Brown. That's another name for you to know. And Rudolf Virchow was the one that concluded that it was responsible for cell division. Okay, so Robert Brown and Rudolf Virchow. Robert Brown first observed the nucleus, and Rudolf Virchow was the one that first described the function of the nucleus. So looking at the two basic cell types, the one at the left would be what kind of cell? Prokaryote or eukaryote? Prokaryote. The one at the right? Eukaryote. You could see all these different organelles in here. Over here, we have the DNA, and that's just kind of in the cell. Here, the DNA is inside the what? What do you think? The nucleus, right? We have the nucleus, and the DNA is inside that organelle, inside that container. That is the end of the section. In review, we have looked at the history of the cell theory. Then we looked at what the cell theory actually is. We spoke about two types of microscopes, and then we looked at the two basic cell types.